Hello everyone. Today we are going to learn about Pulse Width Modulation Unit and UART. First we discuss Pulse Width Modulation Unit. Pulse Width Modulation is a simple method of using a rectangular digital waveform to control an analog variable. Pulse width modulation control is used in a variety of applications ranging from communications to automatic control. The microcontroller do everything with ones and zeros. That means a microcontroller works with 3.3 volt and 0 volt as digital 1 and 0. It can produce, for example, 1 volt or 2.5 volt or any other value different than 0 volt and 3.3 volt. Here, pulse width modulation feature allows us to generate any voltage level between 0 voltage and 3.3 volt. The period is normally kept constant and the pulse width or on time is varied. The duty cycle is the proportion of time that the pulse is on or high and is expressed as a percentage. It is a duty cycle, it is a on time, it is a higher point is a on time and the lower point is off time. It is 100% into pulse on time divided by pulse period. It is a duty cycle. Whatever duty cycle a pulse width modulation stream has, there is an average value as indicated by the dotted line. If the on time is small, the average value is low. If the on time is large, the average value is high. By controlling the duty cycle, we control this average value. The average value can be extracted from the pulse width modulation stream with a low pass filter. In this case, and as long as pulse width modulation frequency and values of R and resistance and capacitance are appropriately chosen, Vout becomes an analog output. In practice, this sort of filtering is not always required. Many physical streams have response characteristics which in reality act like low pass filter. The pulse width modulation in LPC 2148 low power consumption 2148 microcontroller is capable of producing 6 channels of single edge controlled pulse width modulation or 3 channel of dual edge control PWM. UART. Next topic, UART. UART, Universal Asynchronous Receiver or Transmitter, is the microchip with programming that controls a computer interface to its attached serial devices. One of the most common interface used in embedded system is the Universal Asynchronous Receiver or Transmitter. It provides the computer with RS-232C data terminal equipment interface so that it can talk to and exchange data with modems and other devices. UART peripherals typically have several configurable parameters required to support different standards. There are 5 parameters which must be configured correctly to establish the basic serial connection. UART. Baud rate is the number of symbols or modulation per second. Number of data bits. The number of data bits transmitted is typically between 5 and 8, with 7 and 8 being the most common since an ASCII character is 7 bits for the standard set and 8 bit for the extent. Parity. The parity can be even, odd, mark or space. Stop bits. The number of stop bits is most commonly configurable to either 1 or 2. Endianess. Some UART peripherals offer the option to send the data in either LSB or MSB. Serial communication of ASCII character is almost always LSB. RS-232, it's a serial communication port, is a point-to-point signaling standard, meaning only 2 devices can be connected to each other. The minimum connection required for bidirectional communication is 3 signals: transmit, it's a TX, a receiver, it's a RX and ground. The separate RX and TX lines means the data can flow in both directions at the same time. This is called full duplex and it is the standard means for communicating over serial. However, depending on the higher level protocols, there may be a need to be block the transmitter while receiving. This is called half-duplex. Hardware flow control can also be enabled in order to multi-stage the flow of data to optional lines. RTS and CTS are provided for this function. Typically, RS-232 is used without hardware flow control and at full duplex. Advantages: it is low cost interference. RS-232C can provide good performance at low cost. Control and handshake signals ensure that communication success. Easy to use because the IC is available for RS-232C. Voltage level reduces the interference due to noise. Thank you.